Hello everyone, and welcome back to another video. Today's video is going to be on another LeetCode problem. And so, once again, I'm just going to I'm going to read out the prompt, explain the prompt, and then write out the code, explain the code, and then finally end it with the time and space complexity. Okay, so here we have is LeetCode problem number 3. Longest substring without repeating characters. And so given a string S, we want to find the length of the longest substring without duplicate characters. Okay? And so what we have here is like an example. We have example 1, which is the input S. It has A, B, C, and then it hits A again, which we already have the A, so that's a duplicate. So with that, the output is going to be 3. The explanation, the answer is ABC with the length of 3, and a note that BCA and CAB are also correct answers. Okay, and if we look at the topics, or the tags, it's staff, hash table, string, and sliding windows. Okay, so sliding windows is one of those like things that people sort of like use before they really get it. And so like in a way, and you kind of need to know this a little bit. So sliding window is like a moving range sort of in the string, like that. And so you wanna keep 2 pointers. So we have a left. That left is basically the start of the current substring, and then the right, which is the end of the current substring. And so with that, we will have something that looks kind of like this. Like that. Okay? And so the window is literally within that chunk, the left and right. So the rule for this problem is that we want the window to always be a substring with no repeating characters, right? So we have to basically enforce this rule while we move towards the right. And so how the sliding window basically moves is basically our first step is to expand the right side a little bit. And so we move the right forward 1 step at a time. So it's like scanning the string, right? And then so we're going to include this new character into the window. But then if the rule breaks, then we have to shrink from the left. So if adding that new character creates the duplicate right here, so let's just, for example, we have A, and then afterwards B, and then C, and then we add the A again. Now there's a duplicate. Now the window is now basically what you call like illegal, right? You can't do that. So in order to fix it, we have to we fix it by moving the left forward until the window becomes legal again. And by doing that, we basically remove the A, and it becomes BCA. Okay, so expand right, continue expanding right, and then if it's legal, shrink the left, and then now it basically is legal again, then we update the answer, basically. Okay, so it's kind of like that. And what we're basically going to be using that to basically write out the code. Okay, and for this question, there's actually 2 ways to do it, and I'll show both of the ways. Like on the topic, it mentioned it's a hash table. I will be using both a hash set for answering for the first part. I'll answer it with a hash set, and then afterward I'll answer it with a hash map. Okay, so once again, the core idea is we have to think of a window left and right moving over the string. We expand the right 1 step at a time, so we add the characters in, and if we ever see a duplicate character inside the window, then we shrink from the left until the duplicate is removed. And then at every step, the window always represents a substring with all the unique characters. And then we track the max size of such a window. Okay? So, yeah, let's begin. Oh yeah, and just keep in mind, something like, let's say, if I create like this, for example, then as we expand, and then once we get the duplicate, we have to remove the A and then remove the C, and then after we start from B, C, D, A, G, H, and then once it ends, then we know that this is the longest of unique characters without any duplicates. That's how the window sort of works. Hopefully it makes sense. Anyway, so let's first things first, because like I mentioned, I want to use hash set. I'm gonna first import it like that. Let's just add a quick space. Okay, and then first things first, I'm gonna have the hash set. We're gonna have character, and we're gonna call it window, and this will be the new hash set. Boom, boom, boom. And so this part, this is basically set to store characters in the current window, like that. Now we're gonna have integer 0, integer left, and that's gonna be 0. So this is the left pointer, and it's gonna point left pointer of the window, right? Then we're gonna have integer max length, and that's also gonna be 0. This max length is basically our answer. Okay. Now we want to do basically move the right pointer over the string, right? So let's create a for loop. We're gonna have integer, call it right. That's gonna be 0, and then this right is gonna be less than the length of the string, and then right plus plus. So right's gonna increase by 1 at each for loop. Okay. So now we're gonna have this, have that, and this is gonna be at right. Okay, now we are going to write a while loop inside. It's going to be window contains C. So while this contains C, they're going to window remove. We're going to remove the left of it, and then left plus plus. Okay, like that. And let me check if everything's correct. Yep, looks about right. Now we're gonna do window dot add, and we're gonna add the C. Okay. Oh, I should probably comment just in case. Okay, so for this part, so this is basically saying like if C is already in the window, right? Then we're gonna move the left forward by 1, and it's gonna keep moving forward until C is removed from the window, like that. So that's why we have this while statement right here, okay? And then afterward, for this one, let me comment as well. So for this one is that now C is not in the now the C is not in the window, right? Then we can basically add the C into the window. Now C is not in the window, we can add it like that. So don't add it immediately. You want to remove it first and then add the new one in. Update max length with the current window size, like that. So we're going to have integer current length, and that's going to be equal to right minus left, and then plus 1. And then so if and then we're going to check if the current length is greater than the max length, then the max length will turn into the current length. Like that. And once you finish the whole for loop, then we will have our max length, and we'll just return the max length. And that's basically it. So I'll go through like a small walkthrough just to make sure you understand it. Okay, so actually I forgot. Let me explain it line by line first. So right here, like I mentioned, this is the part where we use a hash set to quickly check if a character is already in the current substring, right? So with the hash set, it'll have the contains, add, and remove, and those are usually average of big O of 1. Okay. Now what we have here is basically this set holds the character currently inside our sliding window substring. So if a character is in this set, it means it's inside the current substring. Integer left, left is the start of the index of the window or substring. The max length, it tracks the largest window length, and that we've seen that has no repeated character. For here, right here, what we have is basically right is the end. Like I mentioned, right is the end of the index of the window, right? So we're expanding the window one character at a time by moving to the right. And here, what we have is basically it's the current character we're trying to add to the window. And then for here, like I mentioned, this part is basically the window, if the window contains the C, right? So if C is already in the window, then adding it would create a duplicate. So we have to shrink the window from the left until the C is no longer inside. And so while inside the while loop, we basically get the character currently at the left pointer, and we're just going to remove that left character from the set because we are moving left forward, right? So it's leaving the window. And then afterward, we move the left boundary forward by 1. It's basically shrinking the window. And then this is going to keep happening until the duplicate is removed. Now, once it is removed, now we know that C is no longer in the set anymore, so it's now safe to add it into the window with all the unique characters again. And then for here, this is how long this is how we show like how long the current substring is. So for example, if the left is like 2 and the right is equal to 5, then the length of it would be so like index 2. Let's just show something like this, right? So let's say we are on here and then we are on here. So that should be currently 4. But, 5 minus 2 equals 3, so we have to do a plus 1 at the end. And then that gives us 4, the length of 4, okay? There we go. All right, and so if the current length is greater than the max length, we just update the best answer if this window is bigger than what we've seen before. And then after scanning the whole string, we return the biggest unique substring length. Okay, and now I'll show a quick example. These, I feel like we can use the first example, obviously, because that has it shows us the best. So we have A, B, C, A, B, C, B, B, like that. And let's just add the numbers, the index, like that. Okay, so first things first, we track left, right. So we want to track the left, right, window set, and the max length. So at the very start, it'll look something like this. Here's the start. We're going to have left equals 0, because that's what we have right here. Max string 0, right is also 0. So, oops, sorry. And don't forget, our window is currently empty as well, right now. And then the max length is 0. Now, our right is 0. And so, basically, we're gonna basically add the character C from the right. So we're gonna add this into it. So now our window has a A. Okay. So don't forget, we have to check is there the window does not contain an A, so we add the A into the window. And then now the current length, which will be 0 minus 0 but plus 1. And so now our length is I forgot. I do need to write down our current length as well. Our current length is 1. Okay? And don't forget, because max length is 0, current length is greater than the max, so max length right now will be 1. Like that. Okay? And now the window has a substring of A. Now we have right being 1, because don't forget we have a plus right over here. And then left still being 0. Okay, now we're gonna check now that the right is on number 1, we see that it's a character B. Now we're gonna check, is the character B inside the window? It is not. So we're gonna just ignore this, and now we're gonna add the B into it. So it looks like this. Afterward, you basically just want to check the current length. Current length will be 1 minus 0 plus 1. And so that's 1 plus 1, which is 2. Is 2 greater than the current max Is the current length greater than the max length? It is. So we update it. And now we have to plus 1 for the right because of this right here. Okay. Now we check C. So, or index 2 basically. Which is C. Again, C is not within the window. So what we do is we add it. We're going to update the current length. It becomes 3. 3 is bigger than 2, so we update the max length, and then now we have this. And then add 3. Now on 3, when we check 3, index 3, which has an A, right? Now what happened is we look at this while loop, and it shows that the window does contain the C. So what happened was we must shrink basically from the left. So now the left, which is 0, and that the current left, which is right here, we're going to use this one. It's going to basically have the left become 1, and we have to remove the A now. We basically remove the A from here. Oh, sorry, we remove the A first, and then we do the left plus plus, okay? So now we remove the A, and then now left becomes 1. So now the window does not contain an A, so we add A to the window, which becomes BCA. Okay. Afterward, we do the same thing. Current length, which is now 3, but it has to be minus 1 from the left. So 3 minus 1, which becomes 2, but plus 1 again, which is 3. So our current length is still 3, and the max length stays 3 because the current length is not equal to the max length. This will only be true if if the current length is greater than the max length. Okay? Okay, so now for you do the same thing, right, which is 4, and then now there's a B. You want to remove it, put this onto a 2, make this into a B. I'm just gonna quickly scan through. Current length stays the same, max length stays the same. Now we notice that C is also a duplicate because the right, oh, that's right, we gotta update 5. Now 5, C is duplicate, so we remove the C first, make this into 3, and then add the C, and then we realize current length, max length is still 3. Okay, now we update the right into a 6. We check, it is B this time. So what we do is we shrink until we remove the B. So first things first, we remove A, and then afterward we remove B, and then and then basically left becomes, oh, that's right. You don't do that. You don't do it like that. You want to remove A first, and then it becomes 4, and then afterward you remove B, then left becomes 5. So now window is just C only, but because it's gone, we add the B in. Current length right now will be 2, because 6 minus 5 plus 1 is 2. Max length stays 3, and now we have CB. Now we look at 7. It contains B, so now we have to shrink the C, make it into 6, and then shrink the B, make it into a 7. But then now we add the B back in, because the duplicate is gone. Now we can add it back in. Current length right now will be 7 minus 7, which is 0 plus 1, so it becomes 1. The current length 1 is smaller than the max length, so the max length 3 stays the same, and then right becomes 7. Or the right doesn't matter, but when we get that, we basically all the for loops is basically gone. We return the max length, which is 3, and that's how it works. Damn, that was a lot to say. Holy moly. Okay, but let's just quickly run it first to make sure everything's correct. And we have something wrong. What is wrong here? Oh, is it this? Time exceeded. Now hang on a second. What? Oh. What am I doing? Wait. Yeah. Oops. Wait, I'm actually dumb. I gotta do this. Oh, I forgot to add something. Okay, so it should look like this first. There we go. And then afterward, we want to do the window.remove with the left There we go. Okay. Okay, I just basically forgot to add this in. I just have this instead. Oh, there we go. Okay, what I had was just this. I forgot to add this part. There we go. Okay, that works. Let's quickly submit it. Okay, and then keep in mind, so, nice. That's good. Okay, good. Oops. 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 All right, there we go. Okay, so everything works. So for the time and space complexity for this is that time complexity, each character is added to the set at most once and then remove at most once, right? So overall, the time complexity will be big O of n, where the n is basically the string dot length or s dot length. And then for space complexity, the set can hold at most all distinct characters in the string. So in the worst case scenario for space would be big O of the whichever the minimum of n or the set size. Okay, something like that. So there's that. Okay. So that's basically it for the hash set. Now I will have to show you obviously the hash map. With a hash map, it's like, how do I say this? So it's sort of like an upgrade, I would say. It's not really using the hash map is like a better version of it, but it's still gonna be big O of n, but it's just sort of like cleaner and like faster, I guess, when it comes to in practice. And so I'll show you the hash map example as well. Okay, let's quickly restart. Okay, so we're gonna upgrade the idea a little bit. So instead of a hash set, we're using a hash map that stores the last index where each character appeared. And then when we see a repeat character C at position right, then or here, I'll type it out basically. Okay, so use a hash map that stores the last index where each character appeared. When we see a repeat character C, at position right, we want to do a few things. First things first, if the C was last seen at index, we call it last index, then the window can't start before last index plus 1. So we do something that sort of like looks like this. Oops, not max, math with the left and last index plus 1. Something like that. That's basically the whole trick of it. And so I'll quickly write out the code. Sorry that this video is gonna be long, but it's always nice to write out another example just to show that it also works, you know. Yeah. Okay, so first things first, import a hash map instead of hash set. We're gonna have hash map. We're gonna have the character here and then the integer here. And we're gonna call it last seen. And this would be our new hash map. Like that. Let's have integer left equals 0. And then integer max length equals 0. So same thing. And then right here, we're going to have basically the same thing again, where the right is 0 and then the right is less than s dot length. And then the right plus plus. Now we're going to have character C. That's going to be like this. Again, same thing. Now this part is slightly bit better, I would say, compared to the other one. We don't have to write too much. So if last seen dot, and it contains the key C, and last seen dot get for the C is greater or equal to left, then left will become the last seen dot get C plus 1. this part is basically what I mentioned before. If we have seen C before and it's inside the current window, then move left to one position after the previous occurrence. Like that. Oops, didn't spell it right. There we go. So this part, if we've seen the C before and that it's inside of the current window, then we have to move the left to one position after the previous occurrence. As simple as that. Afterward, all we have to do is just update it. And on the right. So now for this part, it would just basically be update last seen index of C. Oh, and then we also, obviously, we have to update our answer, right? Update answer. So for this part, same thing. Current length is equal to the right minus left plus 1. And then if the current length is greater than the max length, then the max length will update. Like that, and then, oops, and then we just return the max length. Easy peasy. Okay, finally. So, like I mentioned, hash map, it stores the, what we're going to do with the hash map on the last scene. We call it last scene. So basically, stores the character most recent index where it appeared. So for example, if A is at 3, that means we last saw A at index 3. That's why we have the character in the integer. And then, like I already said, the left is the start of the current window. The max length is the best answer so far. What we have here is basically the for loop. Right, it's going to expand the window one character at a time. And then this is the current character that we are at. So this part right here is the most important part because this is where the duplicate like handling basically is. So this part basically means that if we've seen C before and its last position is inside our current window, which is right here for this part, then we must move the left to one position after that position. Okay? And so you would think sort of like, yeah, and by the way, it doesn't have to be this. You can use math max, by the way, instead of the greater or equal to left check. So sometimes, and the reason why we have to sort of do that is because sometimes C can be like sometimes C was seen before, but outside the current window, right? Then we basically ignore it. And so, you know, that sort of basically just tells you that the window already moved past it, okay? And so, yeah, that's basically why we have to use this. Or math max, by the way. And then right here, we just update C to its most recent index, and then we update the max. Okay. So, okay, let's just do like a quick example because this video is going to go on like 30 plus minutes, and that is not good. So let's say, for example, we have A, B, B, A, something like that. And right here, we're going to have 0, 1, 2, and 3. Okay, so on our left, it's going to be 0, and then on our max, it's going to be 0, and then our last scene is going to be looking like this, which is empty. So right now is going to be 0. Oh, I forgot about right. Right is also going to be 0. Okay, so right equals 0 with C equals C basically equals the string of A right now. Okay, and that basically we have not seen it, so there's no move, and then we're just gonna add basically the last scene A is or how do I say it? Last scene is gonna look something like this, like that. Okay, and so the length will be 0 minus 0 plus 1, so that means it's 1, and then our max is gonna be 1. Okay, so our current will be 1, but our max will be 1. So now the window has basically an A here. Okay, now we're gonna go do right being 1, and we're gonna plus it. And so again, it's a B, so everything's fine. Our max is gonna turn into 2. Our it's gonna look like this. Then last scene B is gonna be 1, and now we're gonna have this like that. Okay, And then now we plus the right into 2. 2 has a b, which is a repeat. So basically what's happening right here is it's going to show that, hey, our last scene, actually I can just highlight it. Our last scene b is equal to 1, and the 1 is greater or equal to left 0. This part right here, okay? Left being 0, 1 is greater than the left 0. So that means there's a repeat inside the window. So what we're going to do is basically the left is going to 1 plus 1, which basically becomes 2, right? Because our b has the index of 1, and then we want to do another plus 1 right here. Okay? And then so 2 minus 2 and then plus 1 means the max is going to stay, 2 minus 2 plus 1 equals 1. And because 1 is less than the 2, the max stays the same. We're going to do like this. Okay. And so now, basically the window now only has the b. And by the way, this is the second b, not the first b, okay? So we're on here now. Okay, now the right is going to turn into 3. And 3 has the a, which is right here. This a. And so our last scene, which is a being this one. But the thing is, we have the but. 0 is not greater or equal to the left 2. Okay? Why? Because, well, the answer is no, because like it's outside the window, right? So we just basically ignore it. And all we have to do is we just update it. So update by doing that. Oh, don't forget about that. And then we update the a. And then we basically do the length, which is 3 minus 2 plus 1, which is 2. And, you know, the current 2 is not equal, is not like greater than the other 2, you know? So, because of this. And so we will basically stay the same. And then now our window would look something basically like, well, our window would look just like this. Our last thing, BA. And now, once it's over, we basically return the max length, which is 2, and so that's the correct answer. And now, the thing is, the time and space complexity for this one, it will still remain the same. This will be big O of n, because it's basically like a one pass where each character processed at least once. So, and then the left just basically jumps forward. Now for space, it will be big O of k, where k is equal to the number of distinct characters, there we go, up to big O of n, worst case. That is it. Whew. Okay, that's basically it. And let me just, here, I'll show you, I'll run it, and I'll submit it as well to show you that it works. And see, look, everything accepted, and we're just going to run it. And for this one, hash map, it's a little bit smaller. It looks cleaner, sort of. It really depends, how you want it to do it. For me, I'm fine with both. That's why I was showing both, but you get the idea. All right, thanks for watching. Bye.